Guys, hope all of us are doing fine. My name is Ernest, and this is Ernest Sciences and Mathematics TV channel. I'd like to welcome each and every one of us to our discussion for today. And in our discussion, I'm going to look at a continuation of the concept of Newtonian laws. And these are the three basic laws of the Newton's first and second, and this is specific aspect of third laws of motion, which we're going to look at. So I've given two specific illustrations on my right side of the board in trying to, of course, distinguish this aspect of the third law from the first and second one. And of course, for us to have a specific contrast, we're going to look at this specific case, whereby we had mentioned that basically Newton's first law is going to be describing the nature of objects that are either at rest or in motion, whereby I've just given a specific illustration for an object whereby a particular force is going to be acting on this particular object that is static, and we had contrasted that one with an object in motion given as that. So we said that basically if this specific object at rest is going to be acted on by a force, it's going to be in a state of motion in a particular direction along that, of course, direction of the force, and it's going to be moving with a constant velocity. So in this specific case, we said that this aspect of velocity is going to be a constant, and therefore we are going to expect no acceleration in this particular case. But for the case of a static object, the element of velocity is going to be given in terms of 0, and therefore the acceleration as well is going to be given in terms of 0 given as that. So for the Newton's second law of motion, therefore, we had given an impression of a contrast with this specific first law that dealt with an object at rest or in motion, which of course we said that this specific object for the first law is going to be maintaining these two specific states unless it's acted upon by an external force. Now, in our discussion of the Newton's second law of motion, we said that this specific law is going to be dealing with the aspect of unbalanced forces. And we have decided that this aspect of unbalanced forces is going to be forces which are going to contrast the aspect of equilibrium. Now, in this case, for the first law, these are going to be forces which are going to be under equilibrium, and therefore we are going to expect no acceleration in this specific case. But for the second case, I've given an example of motion in a circle, whereby we see that an object that is moving in a circle is going to be having this specific nature of forces which are going to be balanced. But due to the change in direction of this specific motion of the object, then therefore we're going to see that there's going to be an aspect of acceleration which can be described in terms of this circular motion. And therefore this gives an aspect of the second law of motion which pertains to the behavior of object for which the existing forces are not going to be balanced. So this gave us a relationship of the aspect of a force and the mass involved. And therefore we see that the two variables are going to be the one basically which we can rely on in trying to describe this is a specific aspect of the force on the object using Newtonian's second law of motion. So in this third case, we are going to look at the specific force which is going to be acting on this particular object, and try to see the relationship between the reaction of the object and the force which is being applied on by a second object. So therefore, we are going to assume that in this particular case, for an effect to be experienced, then therefore there has to be two interacting objects. And we had looked at an example of this from the various types of forces which we have discussed in some of our video, especially in the interaction of bodies for the charges and of course the planetary moving bodies and other bodies. So in this case, I've just given an illustration of the magnets, a pair of magnets given as A and B. And the lower section I've given, of course, a pair of items which consist of a jar and a table. So we're going to see that in this first case, we shall have this particular magnet experiences the forces of attraction. And from the laws of attraction, we're going to have a magnet A attracting on B given as that one, and magnet B attracting on A given as that one. Now for the second case, we shall have an interaction as well of this specific aspect of a jar, of course, exerting a force on the table, which we can give in terms of, let's give this one Fj as the force which the jar exerts on the table. And of course, there will be a reaction force, which is going to be a force, of course, in this specific direction of the table, which is going to be, of course, acting on the jar. So for the first case as well, we can have a representation of the force which is going to be experienced by the two magnets of the force of attraction, whereby we're going to have a force which is being experienced at this particular point is going to be a result of a force of B acting on A. So we shall have a force experienced by A due to the presence of a B, and we shall have a force over A pushing this specific aspect of course, B being experienced, or our force over A push attracting on B being given as such. So in this case, these are going to be two attractive forces, and Newton's second law of motion is going to create the relationship between these two forces of attraction due to the, of course, relative presence of these two specific objects. And therefore, we shall have these specific objects being equal in magnitude given as that one. So we shall have this one given as Ft in this specific direction is equivalent to Fj in this particular direction. So there will be an additional statement whereby we'll see that these specific forces which are going to be due to interaction of the objects are going to be acting in the opposite direction. So therefore, we shall have one of the forces given as such, and therefore, as we can see, the specific magnitude or rather direction of these specific forces are going to be acting in opposite direction as indicated from the above diagrams. Therefore, this is going to be summing up the concept of Newton's third law of motion, whereby we can just give it perhaps in terms of the first illustration which I've given on the board, and then therefore we will have just a general example of what these specific forces entail. So for the first case, for A, we're going to have a statement and say that if an object A exerts a force F on B, then B will exert a force negative F. So kindly take note of this specific representation. So we have if an object A exerts a force F on B, then B will exert a force negative F on A. And of course, we have measured the size of the nature of this specific force, and of course, which is of course equal in size. So this force will be equal in size, but opposite in direction. And this, in a sense, from our first illustration of A is going to be giving us a summation or just a sum of the summary statement of this specific aspect of Newton's third law of motion, whereby we're going to see that generally, for the sake of for the case of these two objects, we're going to have two equal forces which are going to be exerting on each, whereby the objects are going to be exerting equal forces on each other. But in a sense, these particular forces are going to be opposite and of course, equal in magnitude. So in this case, this is going to be forming the summation of, or the summary form of Newton's third law of motion, which can, of course, be summarized as for every action, or for every action force, there's on an object, there is an equal and opposite reaction force acting on another object. Which can be given in terms of these two specific cases. But for a general case, we're going to have this specific representation for the Newtonian's third law of motion. So we're going to consider this specific aspect in our various description. And lastly, I'm going to just have a recap of this small aspect of the concept of gravitational attraction, which is we've come across in one way or another, of course, which is going to be assisting us analyze the aspect of weight, mass, and the gravitational attraction given in our different forum, or in this case in our different discussion on the concept of mechanics or motion. So we are given this specific aspect of force given in terms of mass times acceleration. But if we consider acceleration to be acceleration due to gravity, acceleration due to gravity, So in some of its applications, we are going to come across it being given in various dimensions, particularly two which we are going to come across. So in this case, this is going to be depending on the uses of, or of the units are going to be indicated depending on the application of this specific aspect of acceleration, whereby we are going to have the Earth's gravitational field strength given in terms of 9.8 newtons per kilogram. So this is going to be the Earth's acceleration. So as we can see from this specific field, of course, this is going to be the Earth's gravitational field strength given in terms of these specific values. We have talked about the different vector fields. So in this case, this is going to be a gravitational field strength given in terms of newtons per kilogram. But in some cases, we're going to come across this one given in terms of the value of 9.8 meters per square second given as that one. So we're going to have two specific applications. For the first one, whereby we're going to have the gravitational field strength, the Earth's gravitational field strength given in terms of this specific value. And for the second case, we're going to have the acceleration due to the Earth's gravity, of course, which is going to be given in terms of this one. So we can have this one as acceleration due to the Earth's gravity given in this specific. So kindly take note of these dimensions which have been given. So in case we come across it, then we're going to apply it appropriately. So this second one that particularly is used to evaluate the concept of velocities and distance, which of course have been our point of interest, velocities and distance. So as you can see, there's a dimension of 4 meters per second. So therefore, the second application of the acceleration due to Earth's gravity is going to be assisting us evaluate the aspect of velocities and distance. But for the first one, which is going to be the Earth's gravitational field strength, this is going to be used in calculating, of course, the aspect of weights. Now that we can see that, of course, there is an aspect of newtons and kilograms being given in this particular case. So that's going to be assisting us contrast the two given their particular uses in terms of the implication of these specific dimensions which they have been given. So in our subsequent videos, we're going to apply Newton's laws of motion, and these are going to be, of course, in terms of evaluation, be, of course, appearing in one way or another in some of our videos. So in this case, I'd like to kindly request our members to check our description boxes. It's going to contain a link of other similar videos which are going to assist us and comprehend the whole topic of mechanics in physics and other related topics. So that is it for now, guys. Bye, God bless you. Catch us in our next video.